Most of y'all that have turned in the acceleration part 1 have done very, very well. So now we're going to work on acceleration part 2. So we've already done this, and I already apologize for my handwriting, but we already have this equation: final velocity minus initial velocity divided by time. But if we rearrange this, we can also figure out some other things when working with acceleration, like time. Time is actually equal to final minus initial velocity, and it's divided by acceleration. So that's for time. Now if we arrange this again, we can also figure out straight up velocity, which is velocity initial plus acceleration sorry about that, times time. So it's initial velocity plus acceleration plus time. If initial velocity is 0, then it just drops off and it becomes acceleration times time. So let me write the time again, just with alright, and this one becomes alright, so that's for velocity, that's for time. Alright, final here. Alright, so now we need distance, and that's going to equal velocity initial times time plus 1/2 times acceleration times time squared. So initial velocity times time plus 1/2 acceleration times time squared. The good thing about this is most of the time when we find it, our initial velocity is going to be 0. So this equation more than likely becomes distance equals 1/2 times AT squared. It's simple enough, because most of the stuff, it's going to be a gravity problem where you're just going to drop it. So with that, let's go ahead and give you the acceleration of gravity. So the acceleration of gravity is 9.8 meters per second squared. That's just a nice figure to know. We will work with gravity in this class, and that will be the constant that we use for gravity, the acceleration of gravity. Alright, with that, let's go ahead and put some of these into use. So let's go ahead and go to number 7 here. Alright, so it says a car traveling at 30 meters per second encounters an emergency and comes to a complete stop. How much time will it take for the car to stop if its rate of deceleration is -4 meters per second squared? So with that, we'll just go ahead and work this problem down here. Alright, remembering that this is number 7, And our equation for time is velocity final minus velocity initial divided by acceleration. Back to our problem. So we have our initial velocity, we have our final velocity, complete stop, which is 0. So, and we have our deceleration right there. So final is 0. Final is 0 minus our initial, which was 30. And we're going to just divide that by our acceleration, which was -4. So that gives us -30 divided by -4, which gives us a time of 7.5 seconds. Alright, so that's how to use the time equation. Alright, so let's go ahead and go on to number 8. Alright, a car can go from 0 to 60 miles an hour in 8 seconds. What would be its final speed after 5 seconds if its starting speed were 50 miles an hour? Okay, so with this, unfortunately, we do not have the acceleration, do we? We have to figure it out. So that's the first thing we have to figure out in number 8. So it goes from, remember, final minus initial over time equals acceleration. I'm sorry about having my paper down where you couldn't see it. All right. So 0 to 60 in 8. So our initial is 0, final is 60, and our time is 8 seconds. So that gives us an acceleration of 7.5 miles per hour per second. So now we can figure that final velocity. All right, so it's going, remember, it's going 5 seconds with an initial velocity of 50 miles an hour. So V equals, V final equals initial velocity plus acceleration times time. Alright, so our initial velocity in this question is 50 miles an hour since we're already going 50, plus our acceleration, we just figured, is 7.5 miles per hour per second. So it's 50 plus 7.5 times our time of 5 seconds. Alright, so it gives us 37.5 plus our 50. So our final velocity here is 87.5. Sorry about that again. Miles per hour.